see this again. Okay. Yes. So who else is there? Akshay is there. Vijay, Mayank, Tapas, Kaivalya, Mahesh, Mitesh, Vinita, Safik. Good. Okay. Yep. As I said, people are joining in, so we'll just wait for a minute and we will start. I will also grab. Okay, I need to grab my pen. Yes, so I will share my screen, guys, and just let me know if you can see my screen. Here is the sharing, and we will have a couple of things being shared here. Switch off the other bit. Mm, I think my screen is visible. Just type in V if screen is visible, and we will start discussion. What is pre-processor? What is solver? And what is post-processor? Visible, visible. Type in V in the chat box, so I can just get an assurance. I'll also share one more. Okay, 1 second. Share this window. I don't want to share this window. Yes. Thanks. Thanks, Mahesh. Thanks for confirming. And let's start with the actual meeting. 1 second. I will do one thing. I will just share. Okay. Thanks, Safik. Okay. So I'll only share this part, which is one window. Maybe this presentation. Yeah, there you go. Okay. Now let's start and understand what is a preprocessor. Okay. Before this, are you guys ready with pen and paper? Type in PP if you are ready with pen and paper. Okay. I just want you guys to take a lot of notes. We are going to learn many things today. Okay. So just type in PP if you are ready with pen and paper. Quick. Good. Thanks. Thanks, Tapas. Thanks, Mayank. Let's start understanding what is preprocessor, what is solver, and what is post processor. Now, I want a quick survey. How many of you are already working in CAE? Just raise your hand in the chat box or on top of it. I will come to know. How many of you are already working in CAE? Okay, Vijay is working in CAE. Fine. Computer aided engineering. Only Vijay? Other guys? Mayank, Mohammed, Vinita, I know you are not working right now. You are learning. Akshay, Kaivalya, anyone working in CAE other than Vijay? No. All right. Okay. So you all are fairly new to what is exactly computer aided engineering. That's a good thing. The second question is, how many of you are aware CAD tools, CAD, that is computer aided design tools? Or you can type in any name of any tool which you have already worked in, maybe in a college level, maybe in the working environment. You can just type in. Okay, in CAD, you can just type in which CAD tool you have used. SolidWorks. Okay, Creo. Fine. Good. Mitesh says SolidWorks. Mahesh has used Katia. Okay, that's good. So Creo, SolidWorks, Katia. Anyone with Unigraphics? NX? NX CAD? No. All right. How many of you have used finite element method or a stress analysis inside the CAD tool? Anyone did use that? A finite element analysis procedure in a CAD tool, inside the CAD tool. So you may have applied a certain load, a static load, and you may have got some results. Anyone did that? No. Yes, no. SolidWorks simulation. Okay. Mitesh says he has used SW simulation. That's good. Okay. Fine. So we'll try and understand what is exactly this CAE procedure in totality. Okay. So let's start with, I'll just share some notes here. Okay. We will start discussing with preprocessor. But before that, let me add one more slide here. We'll understand to core what is exactly CAE. It is computer aided engineering. Okay. And a popular definition of engineering is it is a methodical approach to solve a problem. Okay. That's a classic and a simple definition. Any problem. It can be a problem with regards to consumer, it can be problem regarding any industrial situation, or it can be any specific problem. But it's a method in which you are going to solve that particular problem. Okay. So when we are talking about engineering, we are not just talking about creating certain concepts. Okay. We are also talking about proving those concepts. Okay. Listen to me carefully. When we talk about uh, when we talk about 3D design, we are only talking about a concept in a 3D form. We may not have selected materials, we may not have selected the loads, we don't know whether it is going to survive, we really don't know how it is going. So when it comes to proving of the concept, the CAE is going to come into picture. Okay. Essentially, computer aided engineering, what it is? It is a virtual prototyping tool. Okay. What is computer aided engineering? It is virtual prototyping tool or methodology. So today's discussion is focused on what is preprocessor, what is solver, what is post-processor, and what are the various industrial tools available, and how exactly you are supposed to choose the industrial tool based on your domain of expertise. So don't forget that unless you choose your domain of interest, this discussion is waste. Okay, what is domain of interest? It will be divided. Last time I spoke this. It will be divided in two types. One is going to be whether you are interested in solid mechanics or you are interested in fluid mechanics. Because mechanical engineering is divided in these two subjects or these two set of subjects. So if you are interested in solid mechanics, how you can judge that? You can simply judge this by understanding your own inclination towards strength of materials or design of machine elements or vibration, that is dynamics, or metallurgy or manufacturing processes. That is all to do with solid mechanics. And then if you are interested in thermodynamics, you are interested in fluid flow, you are interested in refrigeration and all other bit, you are more towards inclined towards fluid mechanics. Okay. So firstly, you have to understand your own inclination is towards solid mechanics part or towards fluid mechanics part. Okay. So I want an answer from you right now. Tell me whether you are interested in solid mechanics or fluid mechanics without thinking too much. Okay, don't think too much and just type in SM if you are interested in solid mechanics and FM if you are interested in fluid mechanics. Let me see. How many of you are interested in solid mechanics? How many of you are interested in fluid mechanics? Okay, Mahesh is interested in fluid mechanics. Tapas in solid mechanics. Mitesh in solid mechanics. Akshay in solid mechanics. Vinita in solid mechanics. Okay, so that's a good thing. Basically, this may not be your final answer. Okay, don't take me wrong. Uh, you may or may not stick to your answer because the interest may change. But I'm just trying to understand whether you have a clear idea of what is exactly the division of two subjects. Okay, this is the first thing. The next important thing is you have to also understand along with this solid mechanics and fluid mechanics part, you have to understand your own interest in a product domain. So what we discussed is a subject domain right now. This we will call it as subject domain. I want you to write down this the methodology of choosing certain domains and then choosing the tool. Otherwise, everything will be waste. Okay. So we discussed about subject domain. Now we will discuss about product domain. And this is also very important. Okay, when we talk about product domain, we are actually talking about the visual product which we have. Okay, so we'll broadly identify some products. Automotive is one of the product domain. Okay, passenger vehicle PV division. So it will have two wheelers, electric two wheelers. It will have regular two wheelers. It will have cars, personal mobility. It will have all the possibilities of transferring an occupant from one place to other. And we call it as personal mobility. Okay, it's not a public domain stuff. So we have, as I said, in automotive, we have passenger vehicle, we have commercial vehicle, we have defense domain or defense vehicles. We can classify it like this: passenger vehicle and commercial vehicle for time being. So you can have commercial vehicles again as buses, trucks, that is highway vehicles, and then you can have off highway vehicles. Okay, like let's say you are interested in cranes, or you are interested in diggers, or you are interested in movers, earth moving equipments, mining equipment. So basically they are going to be an automotive part, but they are commercial vehicles and they work in off highway environment. Are you with me, guys? Okay, so first of all, you will have to understand your domain of interest with regard to subject, and then you will have to understand domain of interest with regards to product. So as I said, passenger vehicle, it can be four-wheeler, which we'll call it as a car, and then you can have a two-wheeler, which is a personal mobility. So this is something which is, or even three-wheelers. So there are personal mobility vehicles which are three-wheeled. They are coming up. There are vehicles which are three-wheeled and they are only carrying two people. And in an aisle fashion. That means one is sitting forward, one is sitting rearward like a fighter jet. It's a very narrow vehicle and it will come. Eventually it will be coming as a quad cycle or a tricycle. And you will see those kind of electric vehicles on the road very soon. So this is one domain. Okay, we are talking about one product domain. The second product domain can be, let's imagine you have railways as a second product domain. So you are interested in railways. You are interest. This is called as rolling stock. Okay, this is a very technical term, rolling stock. So it can be, now there are various things which are going on in India. You have Vande Bharat Express, which is called as a train set. Okay, you have you have a very heavy duty 12,000 horsepower WAC 12 WAG 12 engines which are made by Alstom as per Indian classifications. Um, these are the engines which are for freight movement. Okay, 12,000 horsepower. You can imagine our cars are hardly reaching 100 or 200 horsepower. So 12,000 horsepower is the rated capacity at which the locomotive is going to pull. So you can imagine a small dam uh, may produce a small or a medium sized dam may produce an electricity of 5 megawatt. We are talking about 12,000 horsepower, which is roughly 10 megawatt. Okay, so it draws 10 megawatt of electricity and it runs the entire vehicle or that particular train. Double stack container, you have dedicated freight corridor, all these things. So you have classification as broad gauge lines, main railway lines. Then you have RRTS, which are rapid rail transit systems. You have bullet trains which are coming up, which are very fast railway lines. You have metros which are made to run inside the city. And then you have various other small tram like structures or various rolling stocks which are available. Okay, and you have airport connecting lines, you have airport express lines. All these things are going to comprise of rolling stock, or rolling stock comprises of all these type of activities or vehicles. Then you have third domain of product domain interest, which can be defense. Okay, and I'm trying to focus on something which is growing, something which is going to have future for next 5 or 10 years, not just for 5 or 10 years, but maybe another 25 years or 30 years, because we have a projection of right now we have around 68,000 kilometers of uh, rail lines. In India, the projection is 120 k kilometers. Okay, that is 1,20,000 kilometers of railroads by 2035. Okay, in next maybe 10 or 12 years, we are going to double our railway tracks. So we have this kind of a growth where everything is going to be demanding. There will be coaches, there will be engines, locomotives, there will be all sort of things which are going on. Automotive, of course, it is shifting from it's shifting from regular vehicles, IC engine vehicles to electric vehicles. All these things are happening. In defense, we are talking in a serious term, the Atmanirbhar Bharat. We are talking about self-reliance. Navy yesterday decided to go 100% self-reliant in 2047. So they are not going to import a single nut or bolt, and they are going to develop vendors in such a way that Navy will be the first force which will be 100% indigenous force. That's what their aim is, and that was in public domain yesterday. So defense is another field where you have again you have aerospace, you have naval structures, you have land structures, land systems, you have missiles, all these things. Okay, so if you are interested in automotive, railways, or defense, or general engineering, material handling, so you can list as many domains as possible. So can anyone list how many domains will be there? Okay, apart from automotive, railways, and defense, what comes in your mind as product domain? Energy, yes, very good, Mitesh. Absolutely right. So you have energy domain. That's a good one. Uh, what else can be the domain? Material handling, as I said, can be one of the domain. Okay. What else will you call it as a domain of interest or a product domain? Fast moving consumer goods is one of the product domain, or consumer equipments like washing machine, or refrigerators. They are also being called as this can be also called as a product domain, and which is growing very fast. Okay, so fourth domain can be, I'll just write it down for your own sake of reference. Fourth domain can be uh, consumer goods, or it is also called as white goods. So if you are going to follow, the fifth can be material handling, as I said. Too many things going on in material handling as well. And as industry grows, this is also going to grow. Manufacturing is required, large setups are required, everything is going to be in place. Then you have energy, which Mitesh mentioned, I think. And then you have some fast moving consumer goods, where you will have too much of your input to be given. And oil and gas, aerospace, yes, of course, aerospace uh, is an important domain here, of course. Yep. So what was our discussion? Our discussion is about computer aided engineering. We talked about what is exactly engineering, and we are going to talk about how to choose, or first we will understand what is preprocessor, what is exactly solver, what is post processor. We will understand what are the tools being used in industry, and we are going to talk about which tool and what type of tool you are going to choose in a particular case, and how to choose it. The first a tool, before you choose a tool, is going to be domain of interest. The second is going to be, and I'm talking about subject. Second is going to be the product domain. Okay, that is something which is what we are discussing. Now let's come to preprocessor. So up till this point, everyone understood what we discussed? Is this clear? Type in clear if this is clear. A very specific thing I discussed today. So just type in clear if this is clear. Yeah, Mahesh, thanks a lot. Okay. Mitesh, thank you very much. All right. So let's move on and understand what is a preprocessor. Okay. Essentially, a preprocessor needs CAD as an input. So 3D geometry is an input for a preprocessor. And the preprocessor is going to do certain set of activities on that CAD. The first activity is going to be discretization. Okay. Discretization, which is nothing but actually creating small parts of a large continuum. Okay, so we'll talk about this in detail. The second thing which a preprocessor does is assign materials, boundary condition. So it can be load boundary condition or a constraint boundary condition. Various types of control cards, database cards, all these things. Do connectivity. Okay, connections. These are the main functions of a preprocessor. So we will see what exactly preprocessor does when we talk about discretization. Okay, so discretization is typically called as meshing in layman's term. How many of you have heard? Okay, meshing in layman's term is discretization in layman's term is meshing. Okay, so what do? We have a continuum. And the fundamentals of finite element analysis are, we are not going to analyze every single molecule, but we are going to have a select few molecules which we call as nodes. Okay, because we measure something on these points. All right. And what is going to happen? We are going to join them with a stiffness matrix, and this we call as element. This we call as node. Okay, so we have discretization, which is breaking down an infinite molecule continuum into a finite molecule or finite nodes or finite point structure. Okay, and this is something which is called as finite element method. Okay, because we convert an infinite number of molecules into finite elements. That means which we can measure. Okay. And this discretization needs certain kind of methodology again, because it is essentially going to be an engineering activity. So what is that methodology? So imagine you have a plate like this or a bracket like this, and which is changing its shape. So you have two or three methodologies. If you are going for a static mesh, the mesh will look different. Static analysis you are going to do. If you are going to do impact or explicit dynamic case, the mesh will be a little different. If you are going to do mold flow, the mesh will be different. Okay. And if you are going to do, let's say, CFD analysis, the mesh will be different. Okay. So essentially, the meshing is supposed to complement what type of solving you are going to do. The solver is going to decide what type of mesh, okay, you are going to have. So imagine you have a static mesh, you may have exactly the same number of elements or nodes here and here. So there will be no triangular element. Everything will be like this. It will, the sizes will be varying. Okay. But you will have no triangle. If you are going for an impact case, you will not have this kind of a methodology. What you will have is, you will have certain set of triangles where you will have to maintain the element size. Okay. So the triangles will be like this. Everything else. So number of, for example, number of elements here are 8. Number of elements here will be 6 or even 5. Now this will create these triangles because these two nodes get converted to one. These two nodes get converted to one, and you will have a flow. Okay. And the impact cases need this kind of a flow. The size is very important. Element size is very important in case of impact or a crash. When we come to mold flow, okay, we need all triad elements. Okay, because it's not it's not something which is about stress analysis. This kind of analysis is all to do with material flow, mold flow inside the cavity. Okay. And that's why you will need all triad elements. So in impact case, it will be mix meshing. In mold flow case, it will be all triad meshing. And in CFD case, it is all going to be boundary layer mesh. So boundary layer is very important. For example, you are putting this plate in a wind tunnel and you want to understand what is happening to the edges. Okay. So these edges will have very fine boundary layers, and you are going to analyze what is happening to velocity and all these bits in event of a boundary layer. Making sense? Okay. Understood everyone? What are the mesh things which you are going to do? Just type in, or if you want to write down, you can write down. What is exactly discretization? It is converting a continuum, okay, which is having infinite number of molecules to element, uh, what you can say, mesh, okay, or to a finite element part where you can measure the number of elements, and you can have simple equations will be number of nodes multiplied by degree of freedom. So we have 6 degrees of freedom. So how many number of nodes we have multiplied by 6 degrees of freedom? Those many equations we have to solve so as to get the answer. Okay, that's why it is called as a finite element method. Clear everyone? Any questions? You can unmute and talk. I have given permission to unmute. Just 1 second. Let me see if you guys can unmute and talk. Talk, 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 talk. Yeah, Mitesh, that's correct. It is elements and nodes. That's why my company name is ELENO. That is that is correct. Okay, 1 second. So I'll just see how many of you can meeting settings. I want to check the meeting settings. Yeah, meeting option. Yep. Okay. I I have, yes, there you go. Correct. So I have allowed this access to the access to mic. So anyone has any question about what is the preprocessor doing, or what is exactly happening with regards to discretization, you can unmute and talk. No problem. Akshay, Sundar, Safik, Vijay, Mitesh, Mayank, Hari Krishnan. Anyone has any question, just go ahead. If not, we will move forward. All right. Okay. So let's move on with another set of preprocessor related activity. As I discussed earlier, the second thing, first thing is meshing or discretization. The second thing is uh, assigning materials, assigning boundary condition. Okay. And then uh, assigning or connecting the parts. So it can be welding, bolting, or giving contacts. This is called as connectivity side. So this is the work of a preprocessor. Okay. And preprocessor is going to be a standalone stuff. What is happening in ANSYS, a classic example, everything is done in single window. So you have meshing done inside ANSYS, solving done inside ANSYS, and post processing also inside ANSYS. That's not the case anywhere in the industry. Okay, you have dedicated preprocessors, you have dedicated solvers, and you have dedicated post processors. Fine. So especially in automotive industry, ANSYS has no hold at all. There are very few companies who use ANSYS related tools. Of course, because LS Dyna was bought by ANSYS, they have a direct interaction with the automotive field. But frankly speaking, as far as any automotive giant or original equipment manufacturer is concerned, they have different tools for CFD, which are not ANSYS tools. They have different tools for crash, which are not ANSYS tools. They have different preprocessors which are not ANSYS tools. Okay, so we'll talk about some preprocessors which are widely used inside the industry. Okay, the first preprocessor is Altair Hypermesh. I'm specifically elaborating it. Okay, or Altair Hyperworks, if you call it, because we have two preprocessors. There is one preprocessor called Hypermesh, and there is another preprocessor called Hyper Crash. Okay, so you have Hyper Mesh and Hyper Crash. Both are made by Altair. They are available for students to access on Altair University site. You can access them. So you have Altair HyperWorks as one of the leading preprocessor. Second is Beta CAE, which is a Greek company. So Altair is a American company. You have Beta CAE, and their preprocessor is called as ANSA. Okay, you must have heard this name. This is also getting very popular. It is neck to neck with HyperWorks. So you have a proper meshing software or preprocessor which is active inside the organization. It can be HyperWorks, it can be Beta CAE. The third one, which is a very good preprocessor, is Arup Primer. Okay, this is also very widely used in the industry. Then you have Abacus CAE. Okay, this is specific to Abacus Dassault system, but you have Abacus CAE as a preprocessor. Some people use it. Then you have a free tool called LS Prepost. Okay, it is free for everyone to use, and this is made by LSTC, and this tool is specific to LS Dyna, and this is a pre and post processor both, but it is 100% free. That means you don't need any licensing here. Okay, you can use any number of instances and on any number of computers. So that's one of the pre-processor and post-processor being used in the industry. So there are and there is one more which is catching up, which is called DEP, that is Detroit Engineered Products Meshwork. Okay, Meshworks. Fine. So there are 6 or 7 important CAE preprocessors, and I have listed all these right now, but there can be many such preprocessors uh, on a customized basis. Okay, as per industry's needs, the customization may be possible, and they may have created their preprocessors. Well, one more I'll just list it down, which is called as GNS generator. GNS generator. Okay, so these are the tools which are typically used. If you want to write it down, you can write them down. Most of you may be knowing it. But when people ask me a question, which course I should do, which tool I should learn. My suggestion is learn any one of these two, the first two. Anyone, it can be Hypermesh or ANSA. Because once you understand the methodology of how exactly a preprocessor works, it's not going to be very difficult for you to learn any of the other preprocessor. It's pretty much exactly the same. Okay, so learn any one of the leading preprocessors, either Hypermesh or ANSA, and based on that, and learn only one. Don't learn too many preprocessors. That's not going to be helpful. Okay, you should be learning or focusing only on one of the preprocessor, and you should be choosing a preprocessor based on your solver as well. But these two are very versatile. Beta CAE also supports Abacus, Beta CAE supports CFD, Beta CAE supports or ANSA supports vehicle crash. It supports durability. So it supports most of them. Whereas HyperWorks also supports all of them. It supports Radios, OptiStruct, LSDyna, PAM crash. It supports everything. Okay, so you have these tools. Don't consider them as your domain expertise. They are just the tools. First, you have to choose your subject domain, then you have to choose your product domain, and then you have to look forward for the appropriate tool. Okay, so the answer to which type of or which tool I should choose as a preprocessor can be any one of these two. Okay, very clear answer. So there is no bias here. Both of them are equally good, but you should learn only one of them. Companies don't expect you to have full knowledge of Beta CAE or full knowledge of HyperWorks. Making sense? Okay, everyone, is this clear? Type in clear if this is clear. What preprocessor we have to choose? We will go to solver now. Yes, OpenFOAM is one thing. Nastran is another. Again, Nastran typically the preprocessor. We are talking about solver. So Nastran has their own preprocessor, but that is not very powerful. So when we work in Nastran Suffolk, we typically work with either Hypermesh or ANSA again. Okay, so Nastran has their own meshing tool, but that's not too. It's same like Abacus CAE. So you have Abacus CAE, but it's not very powerful. OpenFOAM is very what I can say. You have too many supports going on with OpenFOAM. It itself is an open source tool for CFD. So there are many preprocessors which are available on a paid basis as well as on a free of cost basis. So you will have to be judgmental when based on your own problem statement. You can go forward like this. Okay. Good. All right, so let's move on to the next part, which is solver. Okay, so we'll talk about solver in detail now. Okay, what are the types of solvers? What is exactly implicit and explicit? What is exactly happening with CFD? Which solvers are used in the industry in a predominant way? I'm openly discussing this so that you will have a clear understanding of which tool to choose according to your domain of interest. Okay, which tool to choose according to your domain of interest. That's why we are going to discuss. So solver, it is going to be, we'll classify it as explicit and implicit. Okay, we are talking predominantly about solid mechanics right now. We are not talking too much about computational fluid dynamics. But when it comes to solid mechanics, you have explicit solver and implicit solver. What is explicit solver? It is time domain solver. That means the inputs are always having, uh, if this is XY plot, X is always time. That means you are going to give velocity as an input, acceleration as an input, force with respect to time as an input, or displacement with respect to time as an input. You will need an explicit solver. Okay, it is a time domain solver. Whereas an implicit solver is all driven by equilibrium condition. Okay, very simple. So you have this pen and consider it as a cantilever beam and you apply certain load, you will be first hand knowing whether you really are able to survive with this pen for the particular load or not. And you just want to check the deflection. But imagine you want to have a drop test done on this beam, okay, which is purely an explicit case, purely a dynamic case. So what is an explicit solver being used for? The explicit solver is typically used for dynamic load problems, impact, crash, blast or drop. Okay, whereas in an implicit solver is used for a static load case where you know that you are going to apply load within limit, typically in a in the yield or in below the plastic zone. You are going to apply certain loads and you don't want a permanent deformation. You are going to use implicit analysis. Making sense, guys? So you have solver, which is classified as explicit solver and implicit solver. A time domain solver is something which is going to be used for dynamic loads, blast, crash, impact or drop. And an implicit solver is typically being used for an equilibrium case. So classic case can be a door hanging load case where you have automotive door opened and it is 100% cantilever section and you don't want it as door sagging. So you want that door to be very steady and you don't want it to sag down. So it is all about the static load. Okay, or you have a roof crush, which is again a static load. It is not time dependent. It is 100% displacement driven. And that is something which is coming under explicit solver and implicit solver. Is this clear? Okay. So we will talk about various types of uses of solver. So first thing, uh, we saw the types of solver. What is the use of a solver? The main purpose of a solver is to solve finite element problem, okay, in most efficient way. In most efficient way. Fine. So you have this four noded element, for example. All four nodes have 6 degrees of freedom. You have 24 equations to solve. Okay, each node will have 6 equations to be solved. If you fix these two nodes, then automatically 12 of the equations are going to get redundant. You don't have to solve them because you know that these nodes are not going to move anywhere. They have 0 degree of freedom. Okay, so you are not having any degree of freedom in this case for these two nodes, and then you have only 12 equations to solve. Fine. So basically, whenever you have certain set of equations to be solved using a numerical method. So main important thing in any finite element method is you are using numerical methods. So if you are, let's imagine you are doing any explicit solving, you will be typically using central difference method for solving. Okay, if you are using implicit code, you will be using any, it can be Newton-Raphson, it can be Runge-Kutta, it can be bisection. It depends on the solver's configuration. Okay, but basis of any finite element method will be the numerical methods. Okay, you don't have to do anything. It's all going in background. But the choice is all dependent on which type of solving you are going to use. So we'll list some explicit solvers and we will also list some implicit solvers. Okay. So you have explicit solvers. Of course, there is LS-DYNA. Then you have, I think I lost the camera. 1 second, guys. Okay, I'll switch on the camera from my, oh my goodness, where is it? So I'm on a laptop camera, just bear with me. So we have LSDyna as an explicit code, Abacus explicit as an explicit code. Then we have Radios as an explicit code, and we have Pamcrash as an explicit code. Okay, so these are the four solvers which are predominantly used in industry. LSDyna is used by almost all automotive companies. Pamcrash is used by Volkswagen Group, and it is used by Renault Nissan. Okay, the entire Renault Nissan alliance. So when we say Volkswagen Group, it will combine everything. So you will have Skoda, uh, you will have VW itself, and Audi, and all these things. They explicit solving. When it comes to Renault, Nissan, and Mitsubishi, they are going to use Pamcrash, or they are using Pamcrash as their main solver. The main creator of Pamcrash is ESI. Okay, ESI softwares. So you can go on the respective websites and see the capabilities. That is a very common thing which you can do. Radios has now become open source. Okay, that's a very good news for students. It's an open source explicit solver now. Anyone can download Radios, and anyone can use Radios. Only trouble is you don't have any support. Okay, so if anything goes wrong, you will have to figure out yourself what is exactly going wrong, and you have to uh, match the results of CAE to physical test by your own self. Okay. Abacus Explicit was used by BMW Group. Now the entire BMW Group has shifted to LSDyna. So apart from these two big companies, everyone uses LSDyna as their explicit solver. Honda, Toyota, Daimler, Tata Motors, Mahindra, Porsche, even Tesla, everyone uses LSDyna as their main solver. Okay, so that's an explicit solver list. You have implicit solver list, which is ANSYS, Abacus. Abacus is it is predominant. Okay, it's something which is used widely. Then you have Nastran, preprocessor for Nastran. I was just trying to understand it all. The preprocessor is Patran. That's the preprocessor for Nastran. Okay, it is used very little, but it is there. For implicit, you have one more thing which is called OptiStruct. Okay, and these are some of the leading tools being used in the industry for implicit solving. So it can be static load, it can be a durability load case. All these things are going to come under implicit case. And for explicit, which is crash, impact, blast, and drop, you will have these particular things which are being used. Making sense with regards to solvers? Okay, clear everyone? Any questions? You can unmute and talk, no problem. Type in clear if this is clear, else we will move forward with post processor. I want to show you some examples, and that way you will have even more understanding. Okay, fine. Mayank says clear, Safik says clear. Sundar, any questions? If you have, you can simply raise your hand, unmute and talk, no problem. All right. Okay. So let's move on with uh, post processor. What exactly a post processor is going to do? Main thing with regards to solvers is they are having no graphical user interface. Solvers don't have any graphical user interface. The solver's task is to crunch the numbers and get the results out. Okay, there will be many results which are going to come out. And what is happening with solver is they are going to use too much of a processor and no graphic at all. So solvers are not going to use any graphic engine. They will only use preprocessor. They will only use the CPU, that is the processor, to solve a problem. The graphic is being used by preprocessor and post processor. So what is the use of post processor? The use of post processor is convert or read these results generated by solver and create a displacement plot, create a stress plot or a strain plot, or use an animation or create an animation. All these activities, or even generate a report, these activities are typically being used by post processor. Okay, so very simple. Wherever you see these red, yellow, green, blue, all these images, they are generated by whom? They are generated by a post processor. So we do have list of post processors similar to list of solvers and preprocessors. So you have Hyperview as one of the leading post processor. You have Meta Post, which is another post processor. You have D3 plot, which is another post processor. You have Abacus CAE as your post processor. You have LS prepost as one of the post processor, where you can do all these activities. You can generate displacement plots, stress plots, strain plots. You can create animations. You can save animations as movie files. You can generate a report. You can do some kind of an automation. All these things are possible with Hyperview, MetaPost, D3 plot, Abacus, and LS prepost. Okay, so this is a list of uh, post processors which are available in the market. So I'll just show you some things right now. I'll just show you some post processor generated content so that you will understand what is exactly happening. Okay, so if you go here, I'll just stop sharing and share with you something else. Yeah, I hope the screen is visible. uh, I'm talking about some instrument panel, floor console, door panel analysis. Okay, and I'll just go get you through what types of analysis we can do and what is exactly happening in post processor. So these images which you see are the outcome of either a pre-processor or a post processor. So this is an outcome of a pre-processor and this is an outcome of a post processor. So you can see a displacement plot, you can see a stress plot, and you can understand what is exactly this post processor and pre-processor is doing. Okay, uh, so you can see this as a displacement plot, a stress plot. You can see an impact, a head impact done onto the instrument panel, and this is a plot generated for displacement. This is a plot generated for stress. The maximum stress you can see is around 54.9 megapascal. So essentially this is the outcome of a post processor. You can see various graphs. So I forgot to mention about an important aspect of a post processor, which is to generate various types of graphs or plots. So essentially this is a very important plot for any head impact. Okay, for an head impact analysis, this plot is called as A3 millisecond plot. Okay, and what is the maximum value of a G which is permissible? It is 80 G. What we are getting right now is around 52.17 for 3 milliseconds. So why this is 52? Because this is 52.17, which is max. But what is the A3 millisecond value? It is even lesser than that. Okay, so we have this. Oh, sorry, this is the 52 one which is there. So not max. Max is around 60. I'm sorry. Max is around 60 G. But what we are getting is around 52.17 for a sustained time of 3 milliseconds. Now this is all generated automatically, generating these triangles or rectangles, automatically giving these values, automatically giving these values. This is called as a post processors task. Okay, so you have some acceleration plots, you have velocity plots, you have animations to be played. So I'll play some animations for you. You can see these graphs of force versus time. This graph if you can see here, this is acceleration in g versus time. Okay, this is all generated by the post processor, right? Now if we see, we saw some displacement plots, we saw some stress plots, we saw some graphs, we'll see some animations as well. So let me share one more screen with you, and that will give you even better idea. So if I share with you this animation, okay. So you can see these loads on seat. There is a frontal impact, there is a seat belt anchorage test. All these things are going on, and we call it as animations. Okay, so they are not, they are animation of a simulation. Okay, so we have simulated it, and now we are animating it. So this is a defense vehicle hitting on a rigid wall. Okay, it's a autonomous vehicle with no occupant. uh, this is one of the case. Then if I show you some cases where we have explosion or a blast, that will be even more interesting. 1 second, what is this? Yeah, this is a material handling stuff. Yeah, I think, yeah, here you go. So you have one of the explosion or a blast case on a rear wheel. You have an explosion case when you have an occupant and no hull or a protecting hull, and you have a case where you have protecting hull and the explosion happens. Making sense? So this is all being generated by whom? It is being generated by post processor. It is being solved by a solver, and it is being generated. So if you go for certain cases where I'll just show you. Yeah. So this is very intricate kind of meshing to be done, or it is required by industry to do this kind of a mesh. So you can do customized meshing for, as I discussed earlier, for crash, the meshing criteria will be different. For static, it will be different. For dynamic, or so, for CFD, it will be different. So in various types of domains, you will need various types of meshing to be done. So you can see an energy graph here. This is a part of post processor's activity. So you can see a kinetic energy getting dropped. You can see a total energy which is constant. You can see an internal energy which is rising, and you can see a sliding energy which is slightly rising, which is essentially what? It's a contact energy. Okay, it's a sliding energy, friction. And this is a graph which represents whether your analysis went correct or not. Okay, you have a total energy being constant, because as per law of conservation of energy, you can neither create energy, you cannot destroy. You can only convert from one form to other, and that is what is happening with this graph. So a kinetic energy is getting converted into an internal energy and a sliding energy. Making sense? So this is something which is being carried out or calculated by a post processor. Okay, so there are many questions in minds of people, okay, students especially. I will learn only pre-processor and I will enter into CAE world. It becomes very difficult. I can only learn a solver and I'm going to enter as an analyst. That's also a very difficult thing. What is important is you have to understand the entire process, learn the entire process, master the entire process of preprocessor, solver, and post-processor, generate a report like what I have generated here. So this is the report. Okay, here we are going to talk about it. We are going to discuss. I have put some comments. I have created some a set of slides. I have represented some images. So all these things combined is called as computer aided engineering. It is not just it is not just meshing, it is not just solving, it is not just report generation, it is all of them. Okay, it is all of them. So you guys have to very clearly understand that when you want to enter into a CAE domain, you are going to first choose whether you will go with fluid mechanics or solid mechanics. Then you are going to choose the product domain, whether automotive or defense or railways or railway seats or whatever it is. And based on that, you will have to search a mentor. Based on that, you will have to also search a tool. And then you have to process yourself in such a way that you know the entire CAE, and then you are going to appear for an interview. If you just go and say that I know meshing, you will keep doing meshing for 2 or 3 years and never get out of meshing activities, and you will never become an analyst. Okay, of course, meshing is a start point, but meshing should not be your career. You are not supposed to be a tool operator. Okay, you are always supposed to be someone who knows the entire process, and then you are going to make yourself as a sustainable career guy. Okay, you should be someone who is having a sustainable career in mind rather than just a career with uh, career in mind which is only with regards to meshing or only with regards to solving. Okay, it should be all. Okay, fine. So this is all what I wanted to share. Any questions you have, any open discussion you want to have, anything you wish to share as per your own personal experiences, you can go ahead and ask me any question. Okay. Thanks a lot, guys. Thanks for listening to me patiently. Uh, let's have any question. I think Tapas has a question. Tapas, you can unmute and talk. I have given permission. So if you have access to microphone, you can unmute and talk. Not a problem. Different types of connections that comes under. So it can be welding, bolting. There will be glue, that is adhesive. These are all the connections which are possible and people do it. So you have RB2, RB3, spot weld elements. It all depends on how the solver is going to solve it. So the types of connections very specific to CAE are also specific to a solver. Okay. So first, if you are doing something in LS Dyna, the connection methodology is different. If you are doing something in Abacus, the connection methodology is different. Okay. Safik has a very direct question. Can you share about yourself? Okay, I started my career. I'm very sorry, I never introduced you in detail. But I started my career as graduate engineer trainee back in 2005. I was a college pass out. It was a campus interview. Again, I had a dilemma. I had two offers. One was with Forbes Marshall, which is in Pune. It is in heat power. And the other company, which was Tata Johnson Control Automotive. Again, this was an automotive company. I had an inclination toward automotive. So I entered into an automotive domain. I started my career as a CAD engineer for 3 months, one or not more than 3 months. I was there as 3 months, and then there was an internal requirement for CAE analyst position. So everyone entered. Internally, we had a discussion, we had interviews, and I switched in the same organization. I switched from CAD to CAE, and then I started working as first 1 month I started working as a machine engineer. Then of course there was too much of a demand, so I learned LS Dyna, I learned Hypermesh, and I started my career as GET CAE analyst back in 2005. Okay, and since then I'm using LS Dyna, so it hasn't changed much. There are few tweaks here and there, but same thing with Hypermesh. It hasn't changed much. Few things here and there, but everything remains as it is. Topology optimization is going to be in both explicit as well as implicit because it is a solver integrated thing. So Mayank, very good question. So Mayank's question is, where does topology optimization come in all of this and what is it? So it is basically an optimization methodology. where for a given load, you are going to optimize for either stresses or for weight or for geometry. Okay, that means the overall size. So if you are optimizing for a given load for a given for a particular stress value, the material will be removed in such a way that the stress path is being carried out, and it is all being dependent on the solver. So you have LSOpt as LS-DYNA optimization tool. You have ANSYS. ANSYS has some optimization tool. I don't remember the name. You have HyperStudy and some optimization methodology in Altair. And then there are solver specific optimization stuff which is going on in each of the solver. Okay. So very relevant question, Mayank. Optimization comes only after you have certain set of analysis done. Okay, you must be having certain set of analysis done, and then only you can optimize. Okay. I have been following you through LinkedIn and watch your content on CAE. Thanks for your knowledge sharing. Thanks, Safik, for joining in. All right, so we have already started a batch for LS-DYNA training. So anyone who is interested in understanding LS-DYNA, or because we teach using the commercial tool, we have the commercial LS-DYNA license, so we are authorized to train as well. We have started a batch for Hypermesh. So anyone has any question with regards to that, you can connect me. You have my email address. You are receiving my emails. So you can connect with me over email. You can talk to me. You can have a session set. We can have a 30-minute or 15-minute session, one-to-one session over phone or over Zoom, and we can talk about it. ELENO is always there to help assist GETs, that is fresh engineers, or those who want to switch from design to CAE. We are always there to assist you. Anyone has any kind of a question and want to have a personal discussion with me, you can ping me. आप बोल सकते हो. We can discuss. We can talk, and you can enroll for our entire CAE master program, and we will be there to assist you in placements. Okay. Thanks, Vijay. Thanks, Mayank, Tapas, Harikrishan, Safik, Mitesh, Mahesh, Mohammed. Thanks for your time. And I have recorded this session, so I'll share with all of you over YouTube. And let's see what are the other comments. Any inputs for fresher due for graduation? Okay. Mitesh, input is, as I said, first select whether you are inclined towards solid mechanics or fluid mechanics. Then select your domain of interest, product domain of interest, and then only you have to select the tool. People do a very wrong thing of selecting tool first. Make sure you are selecting the domain first and then select the tool. Okay. See you guys. Have a great day. Thanks a lot. Thanks for joining in. Bye.
Thank you.